Alright guys, so I've gotten a lot of questions from people saying, Mr. Borsch, taking one derivative, very fun. Can I do more derivatives, right? Can I just take 2 or 3 or 4 derivatives in one problem? And of course the answer to that is yes. So, but let's talk about what that means. So the second derivative, when we talk about that, all that means is that's just taking the derivative of the derivative. So if I ask you to find the second derivative, you just take the first derivative and then take the derivative of that again. And the way you're going to write these is it is usually written as f double prime of x. So you just put 2 hash marks there. Or sometimes you write it with d squared y dx squared. I know that notation is a little weird. We'll talk about that more later in the year, but that just means the second derivative. Okay, so for example, suppose I tell you that f of x equals e to the 5x plus 2x cubed. And I ask you to find, say, f prime of x and, f double prime of x. Okay, so the first thing we need to do is find the first derivative. So f prime of x, derivative of e to the 5x is e to the 5x times 5 plus 6x squared. So when I take the second derivative again, I just repeat this process on what I just got. So again, this is just the derivative of f prime. So when I want to find that derivative there, okay, derivative of e to the 5x, that's e to the 5x times 5, and I still need to have that 5 there. It's still there. It's like a constant in front, plus a 12x. So I could clean that up a little and write that as 25 e to the 5x plus 12x. Okay, so that's how we find the second derivative. So similarly, we could see if we try one that is just a polynomial, it gets easier, right? So if f is like 8x to the 4 minus 3x cubed plus 2x to the 1/2, the more derivatives you take, the more the powers get smaller. So your first derivative here is just going to be, okay, 32x cubed, and then minus 9x squared. And here the 1/2 comes down, so 2 times a half is just 1, because it's like 2 times 1/2 times x to the negative 1/2. Okay, those cancel. So we just have x to the negative 1/2. Now when I take the second derivative here, 3 and 32 is 96x squared minus 18x, and then minus 1/2 x. The negative 1/2 minus 1 is negative 3/2. Right, so you have negative 1/2 minus 2 over 2. Okay, so that would be my second derivative, and that's my first derivative. One thing I do want to warn you, right, like these can get ugly. As you can imagine, you might have to use like the product rule and the chain rule multiple times. So for example, if I tell you that y equals 4 times secant of 3x, and I ask you to find that second derivative, d squared y dx squared, we can see things are going to get a little gnarly here, right? So we'll start with the first derivative. So dy dx, that shouldn't be too bad. So the 4 stays in front. Derivative is secant 3x. Derivative of secant x is secant x tangent x. So this becomes secant of 3x times tangent of 3x. And then by the chain rule, I got to multiply the derivative of 3x times 3. I'm going to clean that up just a little bit to be 12 times secant of 3x times tangent of 3x. But now we can see we've turned into a product. So when I go ahead and have to apply and find the second derivative here, I must use the product rule. And of course, as part of that, I'm going to have to use the chain rule a couple times. You can see things are getting a little out of hand here. Okay, so say we have a 12 in front. So we have secant of 3x times the derivative of tangent 3x. So that's secant squared of 3x. And then by the chain rule, the derivative of 3x is 3. Plus, okay, and then tangent of 3x times the derivative of secant 3x. Well, we actually just found that a minute ago. That was secant of 3x times tangent of 3x times a 3 by the chain rule. Okay, so you can see in this case, the second derivative actually got a little uglier. No need to simplify this, of course. This is totally fine. Okay, so that's the second derivative. Now, you might be chomping at the bit and saying, Boris, can we take a third derivative? And of course, the answer to that is yes. So if you want to find, if you want to find like f triple prime or the d cubed y dx cubed, that just means it's the derivative of the second derivative. And this continues, right? The fourth derivative is the derivative of the third derivative. The 20th derivative is the derivative of the 19th derivative. You could just keep going as far as you want. So for example, if I tell you that g of x equals 3x plus 1 to the 4th power, and I ask you to find g trips prime of 0. Well, this would hopefully be kind of what you'd expect, right? That you just take 3 derivatives, and then at the very last step, then you plug in 0. So we always plug in as our last step. So take the first, take a second, take a third, and then plug in. Okay, and we'll see this kind of works out nicely. So your first derivative, the 4 comes down, so we have 4 times 3x plus 1 to the third power. We have to chain rule the derivative of the inside, so that's 3. Usually what I like to do on a problem like this is combine the constants, just to make my life a little bit easier. So g prime equals 12 times 3x plus 1 cubed. Okay, so then my second derivative then, let's leave the 12 in front. The 3 comes down, so 3 times 3x plus 1 squared. And then we need another 3 right there. Okay, so we have 12 times 3 times 3, so that's 36 times 3, so that's 108. So my second derivative is 108 times 3x plus 1 squared. These numbers got a little bigger than I wanted, but it's cool. So the third derivative here, the 2 comes down, so 2 times 108 is 216 times 3x plus 1 to the first power, times the derivative of the inside again, which is 3. I got to use the chain rule every time. Every time we're taking a derivative without exception, we're always doing the chain rule. So 3 times 216 should be 648 times 3x plus 1. Okay, so now that we've taken our third derivative, now we can go ahead and plug in 0. So g trips prime is 0 is 348 times 1, sorry, 648, so just 648. Okay, so that's the third derivative. And again, the fourth and fifth derivative, you can keep going. One of the nice things about these is if you have a polynomial, the derivatives eventually go away, right? They all go to 0 eventually. Which makes sense, because say you have like f equals, 3x cubed minus 7x squared plus 2x plus 1. If you just keep taking derivatives, eventually all the powers go to 0, right? So your first derivative is 9x squared minus 14x plus 2. Your second derivative is 18x minus 14. Your third derivative is 18. Your fourth derivative, and a lot of times here we just might write a 4 in parentheses instead of just doing a bunch of tally marks, is 0. Your fifth derivative is still 0, and if you keep taking derivatives, you get 0. Okay, so that's what it's like to take a second, third, fourth, and so on derivative. These are our high-order derivatives, and I hope this is something you enjoy. We'll see these throughout the year. Okay, thanks for watching, and bring questions to class. I'll see you guys soon.